one. Looks like this is wild cherry, I'm guessing, or cinnamon. Okay, let's stick it in here. Oh, it went, it snapped shut. Get my tweezers out. Okay, it ate it. It ate a jelly bean. Better just make sure and see if this is cinnamon or not. Yep, it's cinnamon. Uh-oh. Should be fine though. Okay, so you can actually see that it's starting to digest it. You can see the liquid in there. And also, I can taste it on my fingers. It's the cinnamon juice. So the sugar has started to get dissolved in there. You can see it's kind of wet. So it is starting to try to digest it. We'll see what happens to the plant now. He is just loving this red jelly bean. Look at the slobber dripping below. So that's digestive enzymes with jelly bean juice. You can see it dripping down the side there. Okay, here's an update on the Venus flytrap that ate a cinnamon jelly bean. This is really cool. So look how it's red, but then turn it sideways, green. Red, green. Okay, so the ants have found the drip off from the jelly bean from the Venus flytrap here. Everyone's trying to get a piece of that jelly bean. So I had to put a napkin under it to catch all the dripping juices. So it's weird because it seems like it's has a lot more of these enzymatic juices in it than normal. It's probably because the sugar that's in there created this osmotic pressure that sucks in water to it. So it's kind of just been continually dripping water out. So you can see with my jelly bean, it actually took a few days for it to seal shut. At first it wasn't even sealed shut and it was losing that sugar. But after a while, it did seal shut around the edges. Okay, because it did so good eating jelly bean, let's give it some real food now. So here's a fly for it. So an interesting thing to note here is that the Venus flytrap is able to count actually. So the first counting that the Venus flytrap does is it needs 2 consecutive touches of its inner hairs within around 15 seconds. And if it gets those 2 consecutive touches, that's when it clamps shut. But once it's clamped shut, then it has to continually be triggered to release its enzymatic juices, because it doesn't want to expend energy when it doesn't have to. If like a raindrop or a twig fell into it, it doesn't want to try to digest that. And so what it does is it counts how many times the hairs inside of it have been triggered. The more triggers there are, more likely it is it's a bigger bug. And so it clamps down even harder and sends out more enzymatic juices. And it's interesting to compare this to the other leaves. And this leaf is the one where I fed it just the dead fly. So you can see how it kind of eventually clamped down around the edges because I wiggled it around inside for a little bit. But then on this leaf is where it caught an actual live fly. So I didn't get it on camera, but I did notice that I heard some buzzing inside one of the leaves and I noticed that there was a live fly in there. You can kind of see through, if you shine a flashlight in it, you can see it inside of there. And look how much this one has clamped down. It's completely sealed and the space where the fly is so small now. So that's because it got triggered a lot of times by the fly struggling inside of there. We all know that Venus flytraps can eat flies, but surprisingly, they don't necessarily eat those flies for the energy in which they have. Venus flytraps come from an area of the world where there's not a lot of phosphorus and nitrogen in the soil. So instead of getting their nitrogen and phosphorus from the soil, they get it from bugs which they catch, and then they use their nitrogen and phosphorus. So surprisingly, Venus flytraps actually use photosynthesis just like other plants. So they receive light energy from the sun, they use that energy to make oxygen and glucose. But then later on, when there's no sunlight, they use that glucose in respiration to use it as an energy source. So I